Hi folks, welcome back to another tutorial video in the Unity series. Today we're going to be taking a look at how we can implement different camera angles within our game, as well as looking at how we can include a mini-map which is going to be controlled and rendered by a bird's eye view camera. Now the first thing we're going to take a look at is how to implement the mini-map. To do this we're going to need a few components, of which one is going to be the camera. Which technically this system will count towards learning outcome 3 when we come to the assessment, which is all based around different use of camera angles. So you can implement this system when we come to the assessment. We're also going to need a render texture, which is going to take the input from the camera, and this render texture is going to allow us to update a raw image on the scene, which is going to constantly display the 2D scene, which will make up our mini-map. Now the first thing we're going to want to include is a new empty game object, and this is just to keep everything in order in respect to all the components that are required for our minimap system. So right click your hierarchy and click create empty, and you're going to want to rename this to minimap. Now within the minimap you're going to first create a new camera, and this camera should appear within your scene view. Of course it's not within the right rotation, so you're going to want to rotate it to point towards the floor. To do this, go to transform, go to rotation on the x-axis, and you're going to want to rotate it by about 90 degrees. Lift the camera up as soon as you've done this and inspect the camera properties. We don't want the minimap to display 3D objects. It's unlikely that it's going to be the case because most minimap systems display everything in 2D. So you're going to want to change the projection from perspective, which uses a field of view, to an orthographic, which will allow you to increase the size of the 2D projection or decrease the size of the 2D projection. Now, this size property can be used in the future to allow zooming on the minimap. We're not going to implement that yet. So for now, it doesn't really matter what the size is, as long as you're happy with the overall distance between the camera preview and the player. Now the next thing to look at is what other options we need. Now we don't need MSAA, and we certainly don't need the flare layer, the GUI layer, or the audio listener. We've already got an audio listener in our scene, which is going to be our first person controller, so we don't need two audio listeners. So remove all those different components. Now the next thing we're going to want to do is take a look at this target texture. You can see this under rendering path. Now this target texture is going to output whatever the camera's rendering to a texture, and the texture it's going to be outputting to is a render texture. So the next thing we're going to want to do is create a new render texture, which is going to take our camera's input. To do this, right click your assets, create new render texture. Now this render texture, rename it to something like minimap texture. And this minimap texture now becomes the output of this camera. So if we go back onto camera and drag and drop our minimap texture into the target texture field, you can see there that our camera now doesn't display within the game, but instead will be outputting to a texture. Now the next thing we're going to want to do is actually adjust this minimap texture. Now you can see if you left click within your assets onto the minimap texture, you've got different dimensions, size, whether or not it's using anti-aliasing, the color format, depth buffer, etc. You can find out what all these options mean by going to the Unity website. However, for the time being, we're just going to take a look at the size option. Now the size of our render image must output to the same size of the image that's going to be displaying on screen. So for the time being, we're just going to change that to around 200 by 200. And that's going to output to a 200 by 200 image within our UI system. So once that's set up, we can go ahead into our minimap empty game object. And what we're going to do is right click it and create a new canvas. So go to UI and click canvas. Now the canvas, of course, is going to render as a screen space overlay. So we've done this in a previous video in terms of the differences between screen space and world space. And this is just going to take up an image on the screen, which is going to be in a 2D format. Now the canvas itself needs to have a raw image, So it's not going to use an image this time because the image itself takes only a source image, whereas a raw image will take a texture file, i.e. the one that we've just created. So right click the canvas, click UI, and click raw image. So that's going to display in the center of your screen. So what we want to do is go into our scene view and make sure we've got it in a 2D format. So let's cycle round to the center, and we're going to want to move this to the top right. So if you select either the translate tool or the scale tool, and you're going to move this to the top right. Now obviously I'm going the wrong way around here, so I'm going to go that way. Go back to the back. And you're going to want to clamp this like we have done with all UI systems before to the top right. So go ahead and left click the rect transform anchor point and shift alt top right. Okay, so that'll snap it to the top right hand side of our canvas. Now the output texture is a 200x200 size, so we're going to obviously want to change the width and the height of this image as well to 200x200. There we go, and you can see here under the raw image we can take in a texture. So unlike the image, we can now take in any type of texture that we've created, but the texture we want to input now is a texture that we've already created using the camera. So go ahead and drag and drop your render texture into the texture's input on the raw image, and you can see there it's now displaying what the camera is rendering. Now obviously it's a little bit too large at the moment, so you can pop back into your camera and you can just change the size of it. So I'm going to increase it to around there, which looks about right. However, go ahead and just adjust these to whichever properties you wish. Now as soon as you've done that, go ahead and play your game. And you can now see in the top right hand corner that it's rendering and outputting a 2D image of your character within the scene. Now obviously at the moment there's a few problems with this. It's not currently following the player, so if I was to walk outside of the camera's view, so I'm going to run outside there, we now don't know where the player is. So we're going to have to code our camera to follow the player, and it's therefore going to update the render texture every time the player moves. Now to do this, we're going to want to go ahead and create a new script. So go ahead inside your assets folder, under the scripts folder, right click, create a new C# script. Now you're going to want to call this minimap, and it's going to be attached to the minimap camera. So as soon as you've created the minimap script, drag and drop this onto the camera, and you can see that it now appears within the inspector. Now go ahead into Visual Studio, open up your C# script, and the first thing we're going to include is a reference to the player. Now this player reference is going to be of type transform, and it's going to be called target or player, whatever you want to call it. But this public transform will make it visible with the inspector, so we can drag and drop the player object onto this field so we can get its X, Y, and Z position. Now as soon as you've done this, click Save, head back into Unity, and you can now see within the minimap script you've now got a target field. So drag and drop your player into this target field, and it's now going to store its X, Y, and Z position. Now this alone won't make the minimap camera follow the player, so head back into Visual Studio, and you're going to want to include a new method. Now the method you're going to want to include is a late update method, so private void late update. And the reason why I'm using late update is because I want the camera to update its position after the player has moved in update, or any physics calculations have been performed in fixed update. So create a new private void late update method, and the first line we're going to want to include is the new position of the camera. Now the camera's position is going to be stored in a vector 3 because it's going to store an X, Y, and Z coordinate, and we're going to call this vector 3 new position. Now the new position is going to equal the target's position, so the player's position. So make it equal to target.position. Now this again alone won't make it move the camera, so we're going to want to go ahead and include a new line called transform.position, which is referencing the game object that this script is attached to, i.e. the camera, equal to new position. So what this is going to do, it's going to take in the target's position, store it into a new vector 3 called new position, and then move the camera to the new position. Now if we save this, go back into Unity and click play, we can now see that the camera will follow the player, but the Y position that the new position is referencing will also equal the player's position. So you can see there it's now rendering water, which is actually underneath my scene. So we don't want the camera's Y position to equal the player's Y position. Instead, what we want to do is keep it above the player. So we're going to want to go ahead back into Visual Studio and restrict the Y value of the camera. To do this, we just need to include one line, and we're going to say new position.y, so the new position within the vector3 variable, is equal to the transform.position.y. So the new position.y value it's receiving from the player will restrict to the transform.position.y, which is the initial Y position of the game object that this script is attached to, i.e. the camera. So click Save, back into Unity, and when we click play, the camera will now follow the player at its current Y position. Now, after you've done this and it's executed fine, we're going to want to go ahead and also script a opening script, i.e. taking an input from the user to open the minimap. Now, to take an input from the player in order to open or close the minimap, we're going to want to create a new script. Now, it can either be a new script which is specific to this use case, i.e. just opening or closing the minimap, or you can use a pre-existing script attached to an existing object, as long as you can find it easy in the future. So I'm going to be using my player controller script, which is attached to my player, and this player controller script in general allows the player to move around, look around, etc., as well as taking any inputs. So I'm going to open up my player controller script, and the first thing we're going to want to include is a reference to an object. Obviously within our Unity hierarchy, the main thing we're going to want to disable or enable is the minimap root objects, so the empty game object that we created. If we just enable or disable the camera, for example, the image will still display on the screen. So we're going to want to enable or disable the entire game object, so the root object. So inside Visual Studio, go ahead and create a new public game object, and I've just called mine public game object minimap. Now we're also going to need a value to say whether or not this minimap object is either active, either true, or it's not active, i.e. false. So go ahead and also create a new private bool called minimap. A bool, of course, is either true or false, yes or no, and it'll allow us to pass this value into a new function to control whether or not the object is active or not. So I've made my bool equal to false by default. So when the game loads, our minimap will not display. However, you can also set yours to true if you wish, if you want the minimap to display straight away. But for the time being, just copy false and we're good to go. Now, as soon as you've included those two lines, so public game object minimap and private bool minimap equals false, you can go ahead into Unity, and whatever script you've included to control this input and whichever game object is attached to, you can see there we've now got an empty field called minimap. So you're going to want to go ahead and drag and drop your minimap root object, so the empty game object we created, into this field so it can be referenced. Now this alone, of course, won't open and close the minimap, so we're going to want to go ahead back into Visual Studio, and we're going to want to check for the player's input. So all player input checks are done in void update. So find the void update method within your script, or create one if you don't currently have one. And we're going to want to go ahead and create a new if statement to check for the M key on the keyboard. So I've written if input.getKeyDown keycode.m, it's going to do something. Now in this case, minimap, i.e. the Boolean minimap, is going to equal the opposite of itself. So whenever I click the M key, minimap, whatever it is by default, will equal the opposite. So to do this, we do minimap, which is a Boolean value, equals explanation minimap. So what this will do is it will set minimap equal to the opposite of what its current value is. So if it's true initially, then it will now equal false. And if it's false, it will now equal true. Now this value is going to be passed into a function called setActive, which will enable or disable the game object. So we say minimap, which is our game object variable. Note the difference between the lowercase and the uppercase. And we're going to say minimap.setActive, open brackets, minimap, close brackets, semicolon. So this setActive function is taking in the value of the Boolean that we also created. Now, as soon as you've done this, click Save, head back into Unity. My minimap by default is set to false, but you can also deselect this within the inspector as well. Go ahead and click play, and you can now see when the game loads, the minimap is not enabled, and when we press the M key on the keyboard, the minimap is now enabled. Now the next thing to note is the minimap currently isn't displaying any icons. Now icons are a really useful way in which to note any objects around the scene, any enemy players, or even the player itself. At the moment it's very difficult to highlight what's actually going on in the minimap. So we're now going to move on to how we can include minimap icons within our render. Now the first minimap icon we're going to do is for the player, and this minimap icon will take the form of a game object within our scene, just like any other game object. Except this time it's going to take the form of a quad. Now a quad is unique in the sense that it renders only on one side. So it won't be visible by the player underneath, but it will be visible by the camera above. So the first thing we're going to do is open up the player model that we have within our hierarchy. And we're going to right click the player and create a new 3D object called quad. Now you can see there it's created a new quad within our scene, and it is in fact, although a 3D object, it displays as a 2D object. Now within the inspector on the right hand side, we're going to want to go ahead and remove some components by default. We don't want a mesh collider to be on the component because we're not going to be colliding with it. So remove the mesh collider. And you can see there also it's got a default material. So we're going to want to go ahead and create a new material and drag and drop this onto the quad so it renders whatever we want to be seen within the camera. Now, of course, it's not going to work very well like this because if we go to the y-axis, we can hardly see it. So we're going to want to rotate it so the rendered face is going to be up towards the camera. So you're going to want to rotate it on the x-axis by 90 degrees. Move it above the player. So go ahead to the transform tool and move it above the player. And you can see there now that it should represent quite nicely within the minimap. Now just doing this by default will of course allow it to be seen within the minimap. So if you click play and press M, you can now see there's a nice little square in the minimap which will denote our player. However, the problem with this, of course, is that this game object will be visible by any other cameras that we have within our scene. So perhaps if you've got a little camera, maybe perhaps in your game, a CCTV camera that you can switch to, it will also be able to see the minimap icons. We don't want that to happen. So instead what we want to do, we want to make this quad, which I'll probably rename actually to player minimap icon. We want to make this quad on a layer of its own. So in the inspector on the right hand side, you can see there a tab called layer, and it should just be set to default. Now what we want to do is create a new layer for it. So go to add layer and select any of the built-in user layers here and just make a new layer called minimap icons. Now as soon as you created the new layer, go back onto the quad and you're going to want to set the layer of this quad to minimap icons. Now what this will allow us to do is it will allow us to force the other cameras in the scene to ignore this minimap icon. So we can set its culling mask to ignore the minimap icon, and we can set the minimap camera to only render this minimap icon. So within the player, you've either got a first person camera or a third person camera. Go ahead to your first person camera, go to layer, and you'll see there it's default, which is fine. But underneath the camera, you can see there we've got culling mask. So the culling mask should be set to everything by default, but we want to negate the minimap icons layer, because that's the layer in which all minimap icons will be rendering on. So go ahead into culling mask and remove minimap icons from there. Now also go into minimap and go to your minimap camera, and you also want to make sure that the culling mask includes the minimap icons. So the minimap camera is the only one that's going to be rendering the minimap icons layer. Now as soon as you've done this, any other cameras within your scene won't render this quad, and therefore only the minimap will render it. Now to improve this minimap icon, I'm going to go ahead and create a new material. So if you've got a materials folder within your assets tree, make it there. If not, create yourself a new folder called materials. Right click it, create material. And I've already got one created called player minimap material. And inside the inspector on the right hand side, once you've selected material, you can go ahead and change the albedo color to whatever you please. So I'm going to do a nice bright yellow color, and you can also attach an albedo texture as well. So I'm just going to use a default texture that's applied within the standard assets. You can see that I've got quite a few there. So we could use an emo if we wanted to, or emo 3, etc. So I'm going to try emo 3 to see what that looks like. And make sure you go ahead and drag and drop this material now onto the player minimap icon. Now you can see there, even though it's an unhappy face, it obviously represents a player a little bit better than it does just a standard grey shader. So as soon as you've had a little bit of play around with that, click on play, and within your minimap now you can denote your player just a little bit easier. Actually, it's not much easier at all. So I'm going to increase the size of our quad. So go ahead to the scale tool. I'm just going to increase the size of that quite dramatically. Click play now, and you should be able to see that a little easier. There we go. Now we're going to move on to now how to include other camera angles within our scene. You should have already created a first person camera previously, so we're going to go ahead and implement a third person camera. Now it's likely we're going to have some issues here, so we'll encounter those as we go along. Because I've scripted my character, certainly in this game anyway, by myself, instead of using the standard assets, so the first person controller within the standard assets, I haven't got any issues pertaining to movement or look. But certainly if you've used the standard assets, you may have an issue when we implement another camera. So we'll take that on board when we come down to it. For the time being though, just enabling or disabling a new camera is what we need to look at, and then we can deal with any of the issues and the aftermath afterwards. So the first thing we're going to want to do is go back into our hierarchy, and wherever your player is, we're going to want to go ahead and create a new camera. So this is going to be underneath the player. So you can see there I've created a third person cam. Now the third person cam itself has got all the traditional attributes on it. So it's got a camera, it's got a projection, which is of course perspective because we want it to display in 3D. It's got a clipping pane, and I've reduced my clipping pane all the way down so it doesn't have any issues rendering anything before the model. And I've just disabled MSAA. I've got a flare layer, a GUI layer, an audio listener, and I've also got a post-processing behavior on it. So that's the one that's going to take in our effects to display anti-aliasing, etc., all that sort of stuff within the effect examples downloaded from the Unity Asset Store. So go ahead and make sure you set up your camera to exactly the way you want it. And the main thing we're going to have to do is actually set its position within the scene. So as soon as you've included third-person camera, go to your transform tool and just move it to behind the player. Okay, so you can see your model if you've got one in the scene, or certainly if you've only got a weapon or a weapon with arms like we have done in previous videos, you'll be able to just see a floating arm with a gun. So you can maybe go ahead later on and include a model by yourself. So once you're happy with the distance behind the player, and certainly in terms of the angle as well, or the height of the camera, we can now go ahead and start to script this. So the first thing we're going to want to do is go to whatever script that we're taking input on. So whether that be your player controller script, your first person controller script even, or an additional script that you want to create that's going to be attached to the player. So I've just got one player controller. So I'm going to open up my player controller script. And just exactly the same way as we enabled or disabled the game object for the minimap, we're going to do the same thing for the first person camera and the third person camera. So create two new variables, one for the first person cam, and it's going to be of type game object, and create another game object public variable for the third person camera. Now with this as well, because we're using the .setActive method, we're also going to want to include a variable for a boolean for the FPS cam and a boolean for the third person cam. So you can set these to false or true, whichever way around you want. It's likely you've got the first person camera set to true initially and then false when we use an input command, and your third person cam is likely going to be false. So it's just a little bit opposite to mine. But as soon as you've included these things, you can click Save, head into Unity, and you can now drag and drop these cameras into the relevant fields within your script. So third person cam is going to go onto third cam, and first person cam is going to go onto FPS cam. Now we head back into Visual Studio now, and we're going to go to the void update method, of course, because we're going to be wanting to check for input. And in this case, I'm going to use the tab key, but you can use any other key you wish. So we're going to say if input.getKeyCount, key down, keycode.tab, then FPS cam, so the Boolean value for FPM is going to equal the opposite. So if it's true, it's going to equal false now. And third cam, the Boolean value for the third person camera, is going to equal the opposite as well. Then what we're going to do is set third cam, which is the game object of third cam, .setActive equal to true or false, depending upon which one it takes in, and FPS cam.setActive FPS cam. So it's going to take in a true or false value, depending upon what the initial value will be when we press the tab key. Now, if we save this, head back into Unity, you want to enable or disable one of your cameras now. So if you've got first person camera enabled, you can go ahead and deselect the third person cam. So you can deselect that. In my instance, I want to disable the first person camera because I want to have a third person view first. So go ahead and click play. And you can now see when we click tab, it now switches between first person and third person cameras. Now you can go ahead and start to customize this a little better if you wish. Obviously, it's likely you're going to have some issues pertaining to the use of a different camera now, because I think that with the first-person standard assets, the script to control the character is actually on the camera. If it is on the camera, then obviously we've got an issue in terms of movement. So it's likely, therefore, that you're going to want to move the script to move the character onto the root game object instead. If you've got any issues with this, though, you can ask me in class and we can try to adjust it. However, the same exact principle can be applied to any other camera within your scene. So perhaps, for example, you want to maybe script a CCTV camera, so you want to look at it, depending upon obviously what genre of game you're going for. And perhaps you maybe want to include a camera for a death animation. So when an enemy attacks your player and your player dies, you might want to then turn on, so set active the death camera. So maybe you want to make it rotate around the player, maybe on a bird's eye view, and it only displays for a certain amount of time. So go ahead and start to include other cameras within your scene. And certainly all this experience will count towards the assessment because you're going to have to make use of many different camera angles within your assessment to get the higher grades. Okay guys, that's all for today in terms of cameras. We're now going to be moving on to next session where we're going to be expanding upon the certainly the player and the enemy in the form of animations to make them more dynamic and make the player and certainly the physical player, i.e. you, feel a little bit more immersed into the game setting.